Jai Hind everyone, and welcome to this, in which we are going to discuss about force and equilibrium. The content of this lecture is we try to understand what is force, then we will discuss what are the characteristics of force to describe it completely, then we move to the next related to equilibrium under the effect of coplanar forces. We will try to understand what is the meaning of the free body diagram. So, the next what is force? An external agent which can change the state of any body. In very simple words, if an object is at rest and we want to make it move, we have to apply some effort, and that effort is nothing but this is force. If an object is moving with certain velocity and we want to stop it, we have to apply some effort in the opposite direction to the motion, that is also a force. If we want to increase the rate of change of displacement, simple, and if we want to increase the velocity of a moving body, then also we are changing the state of the body. We try to make it accelerating. So, for that purpose, we need to apply some effort, that is also called force. And force is explained qualitatively and first law of motion given by Newton, and it is related to inertia. Each and every matter try to remain in its least state of energy. If something is at rest, it will opposes the change of its state. Why this resistance and where this resistance come from to oppose the change in the state, that is by virtue of some property of matter that is called the inertia. And to break this inertia, we have to apply some external effort, that is force. And then force was quantified by Newton's second law of motion. It is popularly known F is equals to ma, or in other words, it is the rate of change, time rate of change of momentum of a body is force. So, I think it is clear what is a force. So, in simple language, I can write what is force. Force is an external agent to bring a change in a state of a body, right? This is force. Inertia is the internal force, and to break this, we have to apply external effort, that is external force. We generally, the engineers generally deal with that external force. It may change the state, not only from static state to moving or dynamic state. It will cause the deformation in the deformable bodies. It induces the stresses, materials, and engineer deals wide in range of forces, right? According to second law, it is written m is a. M is the mass, A is the acceleration, or F is equals to m. Acceleration is nothing but this is rate of change in velocity. So, it is m v2 minus m v1 upon delta t. This is nothing but this is delta p upon delta t. This is the momentum. Change p is the momentum. So, force is the time rate of change of momentum according to second law of motion of Newton. Then units of the force, SI units is Newton designated by capital N. Then MKS kilogram force. Then CGS it is dyne. In FPS it is poundal. So, these are the units for the force. Now, we come to the next. To describe a force completely, some characteristics need to define. So, first and foremost, force is a vector quantity. Everyone will be agree with this. Force is a vector quantity. When vector is come into the picture, it comprises of two parameters, characteristics. One is magnitude along with direction. So, magnitude and direction is essential. Now, take some example. This is a wheel, and if I apply a force here of 5 kilonewton, this is the center or axle having certain perpendicular distance d. What it will try to make to rotate this wheel like this. Direction is this, right? The same force, if I apply at another point, removing from the first position, I remove it from here, applying the same force, magnitude remains same, 5 kilonewton, having same perpendicular distance, then the effect of this force is it will try to rotate this wheel in the anti-clockwise direction. It means I have given the magnitude as well as direction, and both are same, but the effect of the force changes. It means something more is required to describe it. That is what? Means point of application. So, third point is point of application. If you fix the point of application here at a d distance, perpendicular distance d, or some coordinates you may provide, this should be fixed, direction should be fixed, and the magnitude will be fixed, then the effect of the force will be same. So, it means to describe a force, we need at least these three. First, we must have the magnitude. Second, we must have the direction. Third is the point of application. Now, point of application is this, and direction sometimes it says sense. some authors use sense. It is having this line of action, it creates some effect. Now I change something. Now I change like this. Direction is, sense is same, sense is same, but this distance d prime is less than d. So the movement or turning effect on the wheel will becomes 5 into d prime. So this is m dash and m is equals to 5 into d. If d is greater than d dash, so m dash will be smaller than m. Effect has been changed. It means apart from this point of application, one more thing is also required to be fixed, that is line of action. Line of action. So to describe a force completely, we need to give the information, these four information. First is magnitude, second is direction, then point of application, line of action. If you provide this information, then an engineer can use this information to analyze the effect of the force on the desired element. Now, our intention is to learn about the equilibrium under the effect of coplanar force system. What is coplanar force system? So, coplanar force system is the system in which the line of action of all the force, all the component of forces of this system lies in single plane, that is called coplanar force system. So, there are three possibilities. First is, this is a coplanar force system is two force system. So, what is the equilibrium condition? In two force system, the system will be in equilibrium when both the forces are having same magnitude and opposite in direction. Then it will be in equilibrium. It should be a linear system, collinear system. Two force system will be in equilibrium only in case of a collinear force system. So, if this is an object, here a force 5 kilonewton is applying here, then another force you can apply in along the same direction in opposite, along the same line of action in opposite direction, having the same magnitude, then it will remain in equilibrium. And now, if you try to calculate the magnitude of the resultant of the force, in this case, it remains 0. So, if the resultant of the force on any body is equal to 0, that body will be in equilibrium under the effect of the all forces, whether this is two force system, three force system, or more than three force system. So, this is the case for the two force system. It can only be in equilibrium when this is a collinear system and opposite in direction, magnitude must be the same. Now, next step will be the three force system, So, in three force system, you can use the equations summation Fx is equals to 0, summation Fy is equals to 0, and summation m is equals to 0. Means if the algebraic sum of all the components of the system of forces along the x axis as well as along the y axis is equals to 0, and the moment of all the forces about any point is equals to 0, then the system under the force system or the object will remain in equilibrium. This is general condition, but in 3-force system there is a specific condition when the 3-force systems are, or any 2 forces in the 3-force system are passing through a same point. Then to keep the object in equilibrium under the effect of 3-force system, the third force must pass through the same point. It means if 3-force system, this is an object, this is a wheel, and this is an obstacle on a road, and you want to apply this effort P, try to just roll over this object having the weight of this wheel is W, then this is the point of intersection of P, effort horizontal effort P, and the weight of this roller W is A. Now, my point is, if it is in equilibrium, just to roll over this obstruction, what is the reaction and where it should pass from the point P. This is a tangent, then the perpendicular to this should be the reaction. Reaction should pass through the center, because we have learnt that reactions are always perpendicular to or normal to the point of contact. So, it should pass through the center, and we are aware that normal to the tangent will always pass through the center of circle. But here we want to keep this roller in equilibrium in the condition when it is just about to roll over this obstruction. So, it means this roller is subjected to 3-force system. So, where this third force should pass through, it should pass through where P and W intersect. So, it should pass through this. This is the special condition. When 3 coplanar concurrent force system come into the picture, we have a theorem that is called Lamy's theorem. Lamy's theorem. It makes our problem simpler, can apply. Remember, Lamy's theorem only applicable in case of three forces concurrent coplanar system. Right. So, if this is one force, this is second force, this is third force, this is P, Q, R, this is alpha, this is beta, this is gamma, then under the effect of these 3 forces, if this point A or B, whatever, remain in equilibrium, then it must satisfy this condition P upon sin alpha is equals to Q upon sin beta is equals to R upon sin gamma. This expression we can use in, or is equals to constant. We can say this is constant is equals to K. So, we can say, in other words, P is directly proportional to sine of the angle alpha. What is angle alpha? Alpha is the angle between the other 2 forces. Then beta is the angle between P and R. Then gamma is the angle between Q and P. So, this we can write P is equals to sine alpha, Q is directly proportional to sine beta, and R is directly proportional to sine gamma. This is nothing but this is Lame's theorem. Lame's theorem. If Lame's theorem is valid and if it holds, it means the object which is subjected to concurrent 3-4 system, coplanar system, it will remain in equilibrium. This is this. Now, we move to the third one when more than 3-4 system come into the picture. So, in that case, we have to resolve the forces along the x direction, along the y direction, along the z direction, and check summation Fy is equals to 0, summation Fz is equals to 0, and this is not Fz. We will take in case of the 3-dimensional system, and summation m is equals to 0. We have already explained in the 3-4 system, general 3-4 system, the summation of components along the x-axis, component along the y-axis must be equal to 0, and summation of all movements must be equal to 0, then the body will remain in equilibrium. So, for today, this is about the force and equilibrium under the effect of coplanar force system. We will move further in the next lecture. Thank you.